Hello everyone. Today we would be looking at one very important tool which is widely used in many disciplines, which is decision tree. Although we cover these under the risk management, decision tree may be often used in data science and machine learning. We hope you have had the basic introduction to decision tree in previous subjects in your course, and as a result we would not be going into the basic steps of developing the decision tree, but I will refresh your memory on few things which are useful when using the tool which we are having a look today. So to begin with, I will just show you one image of refresh your memory on what it looks like a decision tree. So as you can see, the decision any decision tree starts with a decision to start with, and there will obviously be chances followed up, and you have a position where it ends. And since this is quite relevant to the current um, events which are happening around, I thought of selecting this image because it gives us a good introduction. So as you can see, there are two treatment plans, and there's a when you move along with the treatment plans, there'll be certain drugs that you can take, and depending on those drugs in different stages, you will get a different outcome, right? So this is what a decision tree looks like, and I'm pretty sure you have studied this thoroughly and you have a good knowledge about this already. Right. So another thing which I would like to say at the beginning is that a decision tree is not a calculation method. So that's not something where you can solve and get an answer, but it's more of a convenience tool. So decision tree would be helpful for you to come to certain decisions when you face certain scenarios where you need to take a decision, but it would not give you a straight clear cut answer on which decision you should select and which one you should decide on to go ahead, but rather decision trees would be helpful for you to understand what are the different decisions available, and the consequences followed by, and the choices, and what could be the potential outcomes if you follow through the certain decisions. So the decision tree would be helpful for you uh, to take quantified decisions rather than just taking arbitrary decisions. The decision tree would be helpful for you to take a quantified decision with facts and figures, which we as people from mathematics background, or people who are working in different engineering disciplines, we always likes to always prefer to see the facts and figures. So that's something helpful. And there are several packages available which have developed throughout and are in a good stage right now. So precision tree is one good example, and that's the package which we are going to use. And tree edge is also quite popular, another package which is being widely used around the world. Also we have the option of using the Excel as well. So the Excel would not give you a nice, good looking decision tree, but if you wish to go ahead, and let's say if you don't have access to these packages because you need to have license to run these packages, then The other option would be to use an Excel. But today we would be looking at the precision tree and trying to understand how we can develop a decision tree using the precision tree package. Right. So to begin with, let's I'll start with the my that's where we can start up with. I'll just show you how you can access. You may know all these things already, but for the sake of introduction, I'll just go through step by step. So you just go to my access web page, and you need to install the Citrix receiver, right? Click on it, and you can enter your ZID and password and log into the system, right? Um, okay, then you can simply search for precision tree, right? So yes, you need to have the Citrix receiver downloaded and installed and running in your uh, uh, personal computer or laptop. So make sure you have it already. So once you click it, uh, you get the access to the precision tree, which is another Excel sheet, but it may take some time to open. Right. So it looks like an ordinary Excel sheet, uh, but it has this tab, the precision tree tab as another tab in the Excel sheet. So this is where you can start your decision tree. Right. So some of the things we would be using today is we would be starting up with the basics today. So we would use the tool decision tree, and we have the option of the decision analysis and sensitivity analysis, which we will have a look later on when we go to the examples. But at the beginning, we would just have a look at the decision tree tool. Right. So another important thing to know in this the decision tree is there are three types of nodes available when you are working with the decision tree. So the first one is the decision node. How you can identify a decision node is through this uh, the symbol or the shape, the square shape. Whenever you see a square shape in a decision tree, that would denote a decision node. So that means that is a place where you will take a decision. So for the sake of explaining, I have this very simple example that traveling to uni, in every morning we would be thinking of this, whether we use the public transport or whether we drive to university. Um, Again, we have this assumption that but the person who's facing this decision has the ability to go through the public transport and drive as well. So that's why there's two decisions. So this is one particular example that we would be taking every day, every morning, right? And there could be two or more decisions depending on the circumstance. So there could be even three decisions, right? There could be another decision which is coming here, which is walking. If you are not that far away, let's say around 1.5 kilometers away, or sort of a thing. And if you enjoy walking, if you are a person who's conscious about your health and try to make the most use the morning hours, then you can simply walk to uni as well. So there could be three decisions likewise, but for the sake of explaining, I'm just using two decisions here. and the other node is a chance node, right? So chance nodes are identified by the circular shape, and a chance node is not a decision node. So this is not within our control. Rather, this is simply the probability, right? Depending on the decision we take, there could be different outcomes, right? So the chance simply determines what the outcome is. So in our example, if we use the public transport, the train could come on time, or otherwise the train could be delayed, right? So that is beyond our control, and there could be certain probabilities associated with each of these chances. And one another important thing is that the outcomes or the probabilities must be mutually exclusive. So that means only one event can happen out of all these things, right? Um, there could not be two simultaneous events happening, right? So the train cannot come on time and be delayed likewise, right? I mean, it has to be um, mutually exclusive and exhaustive. Very important that the probabilities of all these events should add up to one. Okay, so those two are very important aspects when it comes to the decision tree. And as with the chance node and as with the decision node, there could be more than two possible outcomes. There could be three, four, five, whatever it is, but there could be different number of outcomes. But very important, the probabilities must add up to one, right? For every single branch. And the other type of node is the terminal node or the end node. We also call this as the end node. That is where the final outcome is associated with each branch. So that's where our decision tree ends basically. Usually, any final or the terminal node would have a payoff, right? So in this particular example, um, now being on time wouldn't give you any payoff right away, although that is a long term payoff. But if, let's say, the train is delayed and then you need to take pay for a ride share service, if you need to be on time to the lecture, then you may have to spend, let's say, $50, right? So there would be a negative payoff or an expense. So likewise, usually the terminal nodes or the end nodes are associated with a payoff, right? Okay, and uh, so we need the probabilities for chance nodes and we need the payoffs for terminal nodes. That would help us to determine the decisions and the associated costs involved, or what could be the best pathways available. And decision tree illustrates pathways, right? Or in other terms, sequence of events, right? If you take one decision, another chance could happen and that could lead to another something likewise. It's a sequence of events. It starts from one end and it follows through to the end, right? So a sequence of events, right? So let's have a look at